Welcome to the Basic Routing Concepts module. By the end of this module, you should be able to explain the basic routing concepts. Routing, in its most basic form, is the process of moving data between Layer 3 networks. The sample topology shown in the example consists of several Layer 3 networks, all connected to routers. Although routers are the most common devices for performing routing operations, note that many switches and security devices also perform routing operations. Note also that the Internet is a collection of many networks rather than a single network. It is essential to look at the required routing components and how devices running Junos OS make routing decisions. When implementing routing between remote networks, there are two primary considerations: creating an end-to-end communications path and ensuring all Layer 3 devices within the communications path have the required routing information. In the example shown, you can see that a physical path exists between the highlighted networks and the Internet. As long as the physical path is configured and is functioning correctly, the first requirement is satisfied. For the second requirement, all Layer 3 devices participating in the communications path must have the necessary routing information. The devices within the user and data center networks must have the proper gateway configured, which is the router that connects to those networks as well as to the Internet. The gateway device must determine the proper next hop for each destination prefix for transit traffic it receives. Devices running Junos OS use the forwarding table, also known as Forwarding Information Base, or FIB, which is a subset of information found in the routing table, also known as Routing Information Base, or RIB, to make this determination. Consider the simple routing scenario shown in the example. In this scenario, what routing information is required for user A to communicate with a device in the data center network? For any device to communicate with another device, which is outside of its directly connected subnet, a properly configured gateway is required. In this scenario, the device associated with user A must have its gateway set to the router's IP address 10.1.1.1. Likewise, the devices within the data center network need a properly configured gateway address of 10.2.2.1. The router, which functions as the gateway device for the user and data center networks, requires sufficient routing information to determine the proper next hop for the traffic sent between the connected networks. In this example, the router learns the information needed through the configuration on each of the interfaces. The router adds the networks, in which the interfaces are participating, to the routing and forwarding tables. The router consults its forwarding table to determine the actual next hop for the received traffic. Welcome to the Routing and Forwarding Tables module. By the end of this module, you should be able to describe the routing table and the forwarding table. The Junos OS routing tables consolidate prefixes, TCP/IP network addresses, from multiple routing information sources, including various routing protocols, static routes, and directly connected routes. When a device running Junos OS receives multiple routes, or paths, for a given prefix or network, it selects a single route as the active route. With additional configuration, Junos OS supports multiple equal-cost routes. The router uses the active route for each destination prefix to populate the forwarding table. The forwarding table determines the outgoing interface and Layer 2 rewrites information, Layer 2 header information such as source and destination MAC addresses, for each packet forwarded by a device running Junos OS. Devices running Junos OS can accommodate multiple routing tables. The primary routing table, inet.0, stores IPv4 unicast routes. Additional predefined routing tables exist, such as inet 6.0, which Junos OS creates when the configuration requires it. An administrator can create custom routing tables as needed. Here are the common predefined routing tables you might see on a device running Junos OS. inet.0, used for IPv4 unicast routes. inet.1, used for the multicast forwarding cache. inet.2, used for multicast BGP or MBGP routes to provide reverse path forwarding or RPF checks. inet.3, used for MPLS path information. inet.4, used for multicast source discovery protocol or MSDP route entries. inet 6.0, used for IPv6 unicast routes. MPLS.0, used for MPLS next hops. Junos OS uses route preference to differentiate routes received from different routing protocols or routing information sources. Route preference is equivalent to administrative distance on equipment from other vendors. Junos OS uses route preference to rank routes received through the various route information sources and as the primary criterion for selecting the active route. This table shows the default preference values for a selected set of routing information sources. The table displayed shows the complete list of default route preference assignments. Routing preference values can range from 0 to 4,294,967,295. Lower preference values are preferred over higher preference values. The displayed command output demonstrates that a static route with a preference of 5 is preferred over an OSPF internal route with a preference of 10. You can modify the default preference value for most routing information sources to make them more or less desirable. The exception is with direct and local routes, which are always preferred, regardless of the modified route preference value associated with other routing information sources. If equal cost paths exist for the same destination, the routing protocol process, or RPD, randomly selects one of the available paths. This approach provides load distribution among the paths while maintaining packet ordering per destination. The displayed output illustrates this point. Note that if desired, you can enable per-flow load balancing over multiple equal cost paths through routing policy. Load balancing is outside the scope of this module. The example shows the use of the show route command, which displays all route entries in the routing table. As identified in the example, all active routes are marked with an asterisk next to the selected entry. Each route entry displays the source from which the device learned the route, along with the route preference for that source. The show route command displays a summary of active, hold down, and hidden routes. Active routes are the routes the system uses to forward traffic. Hold down routes are routes that are in a pending state before the system declares them as inactive. Hidden routes are routes that the system cannot use for reasons such as an invalid next hop and route policy. You can filter the generated output by destination prefix, protocol type, and other distinguishing attributes. The displayed sample capture illustrates the use of the protocol filtering option. The forwarding table stores a subset of information from the routing table. Within the forwarding table, you can find the details used by a device running Junos OS to forward packets, such as the learned destination prefixes and the outgoing interfaces associated with each destination prefix. The Junos OS kernel maintains a master copy of the forwarding table. It copies the forwarding table to the packet forwarding engine, which is the part of the router responsible for forwarding packets. You use the show route forwarding table, CLI command, to view the forwarding table contents. Note that the Junos OS kernel adds some forwarding entries and considers them permanent. One such example is the default forwarding entry, which matches all packets when no other matching entry exists. When a packet matches this default forwarding entry, the router discards the packet, and it sends an Internet Control Message Protocol, or ICMP, destination unreachable message back to the sender. If you configured a user-defined default route, the router uses it instead of the permanent default forwarding entry. This list displays some common route types associated with forwarding entries. This list displays some common next hop types associated with forwarding entries. When a packet enters a device running Junos OS, it compares that packet against the entries within the forwarding table to determine the proper next hop. If the packet is destined to the local device, Junos OS processes the packet locally. If the packet is destined to a remote device and a valid entry exists, the device running Junos OS forwards the packet out the next hop interface associated with the forwarding table entry. If multiple destination prefixes match the packet's destination, Junos OS uses the most specific entry, also called the longest prefix match, when forwarding the packet to its destination. In situations where no matching entry exists, the device running Junos OS responds to the source device with a destination unreachable notification. The example displays a sample forwarding table and tests your understanding of how next hop interfaces are determined. Although multiple entries might match a destination, the device uses the most specific, longest prefix match entry when determining a packet's next hop interface. The most specific forwarding entry matching packets destined to 172.19.52.101 is the 172.19.52.0/24 destination prefix. The next hop interface associated with this destination prefix is GE0/0/1.0. The most specific forwarding entry matching packets destined to 172.19.52.21 is the 172.19.52.16/28 destination prefix. The next hop interface associated with this destination prefix is GE0/0/2.0. The only forwarding entry matching packets destined to 172.25.100.27 is the user-defined default forwarding entry. The next hop interface associated with the user-defined default forwarding entry is GE-0/0/0.0. Welcome to the Routing Instances module. By the end of this module, you should be able to describe the functionality of routing instances. Junos OS logically groups routing tables, interfaces, and routing protocol parameters to form unique routing instances. The device logically keeps the routing information in one routing instance apart from all other routing instances. The use of routing instances introduces great flexibility because a single device can effectively imitate multiple devices. Junos OS creates a default unicast routing instance called the master routing instance. By default, the master routing instance includes the inet.0 routing table, which the device uses for IPv4 unicast routing. The software creates other routing tables, such as inet 6.0, adds them to their respective routing instance, and displays them when required by the configuration. Junos OS also creates private routing instances, which the device uses for internal communications between hardware components. You can safely ignore these instances and their related information when planning your network. This sample output shows all default routing instances. For added flexibility, Junos OS permits you to configure additional routing instances under the Edit Routing Instances hierarchy. You can use user-defined routing instances for a variety of different situations, which provides you a great amount of flexibility in your environments. Some typical uses of user-defined routing instances include filter-based forwarding, or FBF, Layer 2 and Layer 3 VPN services, and system virtualization. This table displays some of the common routing instance types. Forwarding is used to implement FBF for common access layer applications. L2 VPN is used in Layer 2 VPN implementations. No forwarding is used to separate large networks into smaller administrative entities. Virtual router is used for non-VPN related applications, such as system virtualization. VPLS is used for point-to-multipoint LAN implementations between a set of sites in a VPN. VRF is used in Layer 3 VPN implementations. Note that the actual routing instance types vary between platforms running Junos OS. Be sure to check the technical documentation for your specific product. Welcome to the Configuring a Routing Instance module. By the end of this module, you should be able to configure and verify a routing instance. The example illustrates basic routing instance configuration. Once you configure a routing instance and the device learns the routing information within the instance, Junos OS automatically generates a routing table. If you use IPv4 routing, the software creates an IPv4 unicast routing table. The name of the routing table uses the format instancename.inet.0, where instance name is the name of the routing instance within the configuration. Likewise, if you use IPv6 within the instance, the software creates an IPv6 unicast routing table, and it follows the format instancename.inet6.0. To view a routing table associated with a specific routing instance, use the Show Route Table, table name, CLI command. You can filter many of the common outputs generated through CLI show commands by referencing the name of a given routing instance. This example shows a practical way of viewing interfaces that belong to a specific routing instance. You can also source traffic from a specific routing instance by referencing the name of the desired routing instance. This option is illustrated in action with the ping and traceroute utilities.